All right, so now we're going to look at dependent events. And dependent events are basically the opposite of independent events. And they are events whose occurrences do affect each other. Or you could just think of them as not independent events. So a real life example of those would be if there was a tornado outside, the probability of there being a tornado does affect the probability of Mr. Price going for a run. I'm probably a lot less likely to go for a run if there is a tornado outside. And so if the way that you all will calculate this probability is that if A and B are dependent here, then you calculate the probability of A and B by doing the probability of A times the probability of B after A has happened, given that it has happened. So selecting multiple things without replacement is one of the more common examples of dependent, and we're going to look at that here in just a second. So on this example here, we've got a box that contains 4 red and 2 yellow tickets. 2 tickets are randomly selected one by one without replacement. Find the probability of both being red. So what we're trying to find is that we're picking 2 tickets and we're not putting these things back. So the first ticket that we're pulling, if we're pulling just out of this box, we say, okay, how many reds are there? There are 4 out of 6. But the thing with dependent events is that their probabilities affect each other. So there were 4 reds out of 6 total. And once we've picked that red, we're not putting it back. So the amount of reds that are available on the second one and the amount of tickets total for the second ticket are both going to decrease. So now we've got 3 reds out of 5 total. And these are the 2 things that we're going to have to multiply together. So let's see, 4 times 3, that's going to give me 12 out of 30. I can take a 6 out of both of those to give me 2/5. So the biggest thing that you have to recognize is that generally the numbers with conditional probability, they are going to change just a little bit. And so then I want you all to pause it here and then try to do this B here by yourself. So pause it here and then I will go ahead and work this out for you all and then just see if you're getting the hang of it here. So we're going to find the probability of the first being red and the second being yellow. So the first ticket here is going to be still the same probability, 4 out of 6. But the second ticket here is going to be 2 out of 5. And then we're going to multiply those to get 8 out of 30. Or you can reduce that to 4 out of 15. So then the last example here for dependent probability, we're going to do, sorry, I didn't write the page number for this. This is on page 266. If you're wanting to follow along in the book. So we've got we've got 2 boxes of flowers here. We've got box A and box B. So one has, the P's here stand for purple flowers. The W's here stand for white flowers, and we're wanting to find 2 different probabilities here. So the probability that being taken from box A and that it's going to have white flowers. And we are on B going to calculate that the plant has purple flowers. So what we've got to do here, so if it's being taken from box A and we're picking that by flipping a coin, we have to take into account here a couple of things that can happen. So I'm going to draw a tree diagram to help us out here to kind of illustrate. So the probability of picking from box A or B randomly, we're just flipping a coin, is going to be 1/2 for both. Because if we're flipping a coin, our choices are box A or box B. So then if we're talking about the flowers here, so that was for the box. For the flowers, we can either go purple, so out of box A, there is 2 out of 6 purples, or you can just make that 1/3. For white, there are 2/3. And for B, oh man, this tree diagram's not going super great, but we'll live with it. For B, there are 5 out of 6 purples, and there are 1 out of 6 whites. Okay, so the probability of it being taken from box A and it has white flowers, we're going to say, okay, well, box A is 1/2. And then, let's see, we need white flowers, so we're going to multiply that by that 2/3, which is going to, those 2's actually can just go ahead and cross out to give us a 1 out of 3 chance. So then, if we're trying to find the probability that we pick one at random and it has purple flowers, we've actually got to calculate 2 probabilities first, because we could pull purple flowers from box A or we could pull purple flowers from box B. So what we've got to do is we've got to calculate the probability of getting purple flowers from box A and B and then combine them. So for box A here, the probability of getting purple flowers is 1/2 times 1/3. And then for box B here, the probability of getting purple flowers is going to be 1/2 times 5/6. And we're going to have to add those probabilities together. So let's see here. That's going to give us 1/6. This is going to give us 5 out of 12. And then for us to combine these two, we'll have to get a common denominator on this last one here, because you cannot add fractions unless they have the same denominator. So I'm like, what can I multiply 6 by to get it to be 12? That's 2. So this is the same thing as 2/12 plus 5/12, and that's going to be equal to 7/12. So that, in a nutshell, is dependent probability. So if you all have any questions at all, feel free to ask me on Zoom. Feel free to ask me on Google Call. Whatever works for you. Thanks.